So the IDA project is actually not due for a few weeks. The order of turning them in is not quite as logical as it ought to be. But anyway, the one that goes at the lecture is way down here, IDA Pro. So let's talk about this one, PMA 303. All right. And I'm using IDA Pro Free 7 in this one, which you can get, and it's the one included in this Windows 7 tool with tools, Windows 10 with tools. So I'm going to shove this to the side and use my Windows 10 with tools. And it has IDA. All right, and by the way, it doesn't really matter whether you use 5 or 7. I think the difference is very small. Oh, another thing I wanted to mention is your Windows 10 may have expired. It might be complaining in the corner that it's expired. So if that happens to you, you can just easily execute a command. I thought this was kind of hilarious. There's a command to extend your trial, and the background tells you it won't work. And I tried it, and it works. They're just lying. So all you do is go here to PMA 41, and I put it right at the top. If you see license expired, I think that means the background will turn black, and it might even like shut off after every 2 hours of use or otherwise annoy you. So all you do is slmgr/rearm, an administrator command prompt, and then restart your machine, and then you get another 90 days. And I think you can do that like 4 times or 5 times. You could back in the days of Windows XP and Vista, and then supposedly they turned it off, but apparently not. Apparently, because I did it to mine, and I'm back with another 90 days, as you can see. So anyway, that's important to know. If you're using my machine, you went to Windows 10 I provided. I made it 90 days ago, and I thought I might have to remake it, but apparently not. You can just rearm it at least once, so I guess we can just keep using it, which I appreciate, and I don't have to bother. Yes, that's right. So it'll tell you in the corner how many days you have. And if you're using my machine, it ran out a few days ago. So do that, slmgr/rearm. Anyway, that's a good trick, and I'm glad it still works, although it's kind of funny. If you read that background text, it's just not, I'm not showing on this one, but it's the default background text says, don't bother trying that on Windows 10, it won't work. But they're lying. Anyway, so let's run IDA. I said IDA. There we go. So here's IDA freeware. And so the first thing it asks you, this is version 7 freeware. So I'm going to disassemble a new file. And I'm doing one of the malware samples from the textbook. So that is desktop, Malware Analysis Labs. I'm looking for Lab 0501. So it's chapter 5. There it is. And it's a DIL. All right. And so it's going to offer me a bunch of options to control what it does. And I'm just going to take the default options and say OK. And now it's going to start analyzing it. So it has a window down here that shows you what it's doing. It's reading exports, reading imports, applying fix-ups. It's doing a lot of work to analyze the file. So it tells you loading it into the database, and you just have to wait. And it's there. Now it's starting, giving you more messages. Now here's the bar, this yellow bar with black in it, and you see it's slowly filling in the colors. It's still analyzing as long as it's changing this bar, and it shows you down here in the bottom corner what it's doing, every function or memory location it goes to or something. Now it's filled in some of the functions. Now it's filled in some of the code, but it's still working away. Like I say, it takes a while, and with big files it takes even longer. It's really got to do an awful lot of work. And by the way, I think we'll get to this later in the class. It's guessing. You can write code that IDA cannot disassemble correctly. IDA is making assumptions and guesses, and you can fool it. But normal code created by compilers from normal languages like Visual Basic or C++, it understands that. But it is assuming that this code was written by a compiler. And if you maliciously modify the code, you can make it so it confuses IDA, and IDA gives you the wrong commands. Anyway, now it's done, I think. The initial analysis has been finished. Okay, so here we have graph mode showing this, and you can drag this around. So this would be the entry point, DIL entry point, because this is a DIL. So it has this stuff, then it goes to a jump not 0, and it has 2 paths, one way or the other way here. And notice I don't have any addresses here. So if I want to see them, I got to go to Options, General, and then use prefixes, line prefixes, and turn the number of opcode bytes from 0 up to something like 6. And now I'll see the addresses, this memory section, the raw hexadecimal bytes, and then the assembly code here. So this is glorious graph mode. And here's a list of all the functions, and here's an overview of the graph mode shrunk down. I usually find these things to be not very useful and close them to get rid of them. You can get them back. If you go to View, Open Subviews, you can get any of many, many windows here. But I usually like to preserve my desk space for this stuff. And if I hit spacebar, it will go back to Text View, where it doesn't bother to give me the, break it up into chunks. It just shows me the code this way, just instructions and addresses. All right. So let's see what else to do here. That's text mode. Okay, so I'll go back to graph mode. Now, I would like to find the DNS lookups, to find the command and control server for this malware we got here. So I'm going to go to Imports, which is View, Open Subviews, Imports. And those are the functions it uses. And one of these is going to be get host by name. So I can sort it and then look for the G's. The only problem is this is a stupid sort. It's sorting by ASCII numerical value. So the capital G's are totally far from the little g's. The little g's are way down here, starting over again. So that could give you a little bit of a headache. But there it is, get host by name. So when I find that, I double click it. And now I have made it to the storage of that external reference to that thing. And I want to click Get Host by Name. That will highlight it and show it up here, a standard call. And now I can hit Control X to get references to that. Control X. This gives me the cross references to Get Host by Name. So you see there are quite a few calls to this, quite a few DNS lookups are done. And you could look for them one by one, but in the instructions I tell you which one is interesting. And I think it's the second one from the bottom. No, it's not. It's the 163CC. No. Right, okay. It is the seventh one from the top, 1656 plus 101. 1, 2, 3, 4, 5, 6. I guess this was, yeah, now that's interesting. This is different than 101. So it actually has done a different kind of resolution here than it did when I prepared the project, which is a little strange, but you can't have everything. So anyway, this is the one. And so, okay, double click it. And you see it somewhere in here. Here it is, calling get host by name. Okay. All right. And I'm looking to see if it looks like it ought to, and I think it does. Yep. No, it looks like I've got the wrong one. Oh, here. That's interesting. There's two of them right here. Well, I wanted the one that was at near 1757. So I'm going to go back and hit Control X again and see if I can figure out which one is going to go. Oh, here's the one. Oh, it's down here. These are not in the order I expected, which is interesting. Okay, so it is the one that matches. I had to get the one that was 1656 plus 101. And I said the seventh one from the top, but now it's like sixth from the bottom. All right, well, watch out. But this is the one we want. Okay, that's the one that matches it. See, this is RDO. Okay. That's where we want to go. And okay. So right here, This is you can see it, IDA Pro is helping you. It's putting in it's putting a reference to a string. This is RDO pix.practical malware analysis. Then it's going to add 13 to it, which looks like it might be the length of this string, and push that on there, and then it's going to call this. And what this probably is the length of the domain name and the string pointing to the domain name. But anyway, I'd like to see this string that it pushed up there. And in fact, I think it's not the length, but it's the offset. So anyway, I'm going to double click offset this address here. If I hover over it, you see, if I double click it, it will go there. Now here I am in the data storage. And this is a string storing practical malware analysis. And so if I want to see it more clearly, I can go to Hex View 1. And there we are. Now, I should see this is RDO pix.practicalmalwareanalysis.com. I see it down there. This is what I was looking for. So it has this is RDO thing. I don't know why that's there. But then it has this pix.practicalmalwareanalysis.com, and that is the domain name. That is the command and control setter, the command and control server domain name, which is what you're getting here. Anyway, so that's the first thing. You can look for DNS resolutions, and this, by the way, is, I imagine, what Marcus Hutchins did to shut down the malware that was shutting down hospitals that was based on the NSA's malware. He did a quick analysis, and within a few hours he found the domain name that it was trying to call to, and he found that the domain name had not been purchased. So he just purchased that domain name, and that turned off the malware and saved the American hospitals, made a hero out of him. But he didn't know that was going to happen. He was doing something like this, or even something simpler like Ollie debug, or even just strings, and he found this domain name in there and just went and looked. But it turned out that domain name was the shutoff switch, which is kind of a screwy way to do it. But anyway, that's what they did. So now what we're going to do is, that's the first one. Now I want to find flagged code that references cmd.exe. So I'm going to go View, Open Subview Strings. All right, and now I've got all these strings, and I want to find cmd.exe. So I'm going to sort them again. And it's going to be //cmd. So there is the backslashes right there. So 2 backslashes will be, there are the 2 backslashes there. Okay, so there it is, //cmd.exe/c. This is how you launch something in the command line. Didn't the attacker leave that on purpose? Well, I don't know if anybody ever knew that the attacker left that on purpose. I mean, apparently, who knows? You know, that was WannaCry, and we never really found out what was going on with WannaCry or shadow brokers. It's almost certainly the Russian military having stolen it from the NSA. Then they impersonated, pretended to be somebody else like Ukrainians. And then they corresponded with WikiLeaks. There's a lot of international stuff going on there. A lot of military deception involved in that attack. So we never even caught the people that did it. We never even really proved who did it exactly. You know, we don't really know the whole story there at all. Anyway, so here we are, cmd.exe. And I think I double click it to get where I'm going. Yep, that'll get us to where this string is used. Okay, here's where that string is stored, /cmd.exe. And I can go back to IDA View A to see it in text mode. There it is being referred to. And I can hit Control X. So click the word CMD so it's highlighted. Then Control X to see where it's referred to. And there's only one location where it pushes an address to this string. So double click that. And you'll get to the code that does this. And now you can read this code, and here you just use the same technique that I always recommend. When you're faced with a screen full of confusing junk, look for the easy part, and the easy part is almost always on the right and the bottom, because the experts are reading this stuff, but the beginner stuff is over on the right and the bottom. So here's the readable strings. This is cmd.exe/c. cmd/c is how you run a command line and then close that window when you're done. And this is command/c. command is the Windows 16-bit command shell used in Windows 95. So this is the 32-bit version, CMD. So, and if you look up here, it's called Get System Directory, and then compare it to something. And I think it went from System 32 to System, right? So if it gets the System Directory, if it is System 32, it goes to the 32-bit CMD. If it's not System 32, it goes to the 16-bit CMD. So this is like old malware targeting like Windows XP when it was 32 bits. I see some questions. Does ASLR affect our analysis? No, not at all. And that's actually an issue. Since you never actually run the program, it never really loads. It just puts things where they should be in theory. Absolutely. And that's why there was something in the last lecture we were talking about. If you run Ollie and IDA at the same time, the addresses will not match. And that's an issue. And there is an option in IDA to change the base address to try to make it match what you see in Ollie, if you're going to do that. Exactly. But you've got it exactly right, MZ. Anyway, so now you can scroll back here and see what's going on with this malware. By just reading the strings, you can figure it out. So here there's something called D. That's not very informative. But if you go back a little more, there's going to be, here's a carriage return line feed. I'm just reading the gray text. There, here, hi master. So this is a bot. And it sends a signal back to the master saying, hi master. And if you hover over it, it sees, are you enjoying today? Machine uptime, machine idle time, and so on. This is the report from the bot calling back to the bot master saying, I am your slave. Do you have a command for me? And that's the point. So it sends some kind of message back to the master, and then the master can say, execute this command, and it will then figure out whether it should be using a 16 or 32-bit command shell to execute that command and execute it. So this is remote control bot software. And we also found the domain name of the command and control server. So we found some pretty good, useful bits of information about it here. And there's a lot more in the textbook if you want to go through it, but this is a little bit of how to do some simple things with IDA. And there's, then I have some challenges, which I rewrote, but I got them from the HoneyNet project, which was a European training in malware analysis I took that convinced me I could write this course. And so there's a couple simple crack bees. I wrote some simple 32-bit code, and these are very much like the ones that they had like an in-class CTF, which is what I liked best about that class. So what I did was I wrote some simple 32-bit code, and I didn't really understand how to compile it very well, so you have to actually download a DIL to go with it, which is kind of unprofessional. You have an exe, but you also need to download this mscvr100d.dil. If I was more pro, I would tell you which one of the Microsoft redistributable C++ runtimes you have to install, but I didn't know that. I just found that if you put this in the same directory, it'll work. So there are 4 programs here, and I'll show you one of them. Drag them, download the exes and the DILs and put them in the same folder, which I put in IDA. All right. And now, just let me turn on a light. It's getting too dark. All right. All right, and these programs are just simple command line guessing games. So if you do a directory, I just put the first one here, crack me. So if you run that, it says you have to give it the executable and then a password. So if I get a password of P, it says fail. And it will continue to give me fail until I have the right password. And there are, of course, a lot of ways to get that password, but the way we're going to do it is by using IDA, because we're just going to practice with IDA. You could use a lot of other ways to do it, like strings or Ollie, but we're here to practice using IDA today. So you run IDA, and we're going to do a new program, and it's going to be that C IDA. When you have complicated applications, how does IDA treat them? It's a good question, and I haven't done it. I think you can load them all. I know you can load them all in Ghidra. Ghidra is the free IDA competitor, and we'll play with that pretty soon. But I think it can load them all. I think IDA can in principle handle everything, but I've never done it. So here's this crack me. The input file was linked with debug information, and the symbol is here. Do you want to look for that file on the Microsoft Symbol server? And I will say no, because of course it's not going to be there. This is not official Microsoft software. In fact, I didn't intentionally link it with debug information. I guess that means when I compiled it, there was a PDB file in the directory that I didn't notice or copy over. Anyway, now it has loaded it. It's filling in the bar. It's still processing it. And now it's done. The initial. Now this is something I've seen happen a lot. It shows me nothing useful. It shows me some early Microsoft code to launch the program and not the real program, which is very annoying. So the way I get around this, there might be some other brilliant way. I'm seeing some kind of early preliminary launcher here, not the actual program. So I just go to strings, view, open subviews, strings. And then I look for strings I can understand, like right here, fail. You found the password. Fail is the message. So these are the part of the code that I want to look at. So I double click that. And now I get the message fail stored, and if I double click the xref, it'll take me to the code. So now I've made it to the code. Now, I don't know why IDA dumps me off in some earlier part of Windows, but this is the code. So now I can just read this the same way. So here's where it starts. It does some stuff which I don't really care about. Then it has a string called top secret. Here it does some kind of comparison, and it makes a decision. Oh, here. Okay. So what it's doing here, it's comparing something to 2. And if it is equal to 2, it goes here. And if it's not equal to 2, it goes here. And then it prints the message. This is the usage message. It's counting the number of arguments in the command line. If it got the name of the program and a password, then it goes over here. If it didn't get the name of the program and a password, then it prints the usage message saying you have to give me the name of the program and a password and then quits. So that's what this 2 is. Now over here, it's going to load a string top secret, and then it's going to do some kind of compare. And here, if it's going to either say you found the password or fail. So obviously the correct password is top secret. It's comparing to that. If they're equal, I find the password. If they're not equal, I don't find it. And you know, I didn't even read hardly the assembly code at all. I pretty much just looked at the strings and the constants. But the strings pretty much tell you the whole story. So if that's true, the answer is top secret. And let's try that. When you close IDA, it's going to offer to save a database, which means you might have been renaming functions and stuff and remember all that. I'm not doing that. But of course, if you were really analyzing big malware, you would be doing that. And you would want to save a database of all your annotations. But I'm going to not save it, which they put in capitals because that's not the normal way you use IDA. And so that means apparently the answer is top secret. And it is. Okay. So that's how you can analyze this stuff in IDA Pro, and there's 4 challenges here of increasing difficulty, which you can analyze that way in IDA Pro to see how they work. And I think that's it for that one. So I'm going to stop this recording.